We are going to continue on in Unit 4 and discuss more concentrations of solutions. So in the previous lecture, we talked about percent concentrations, which we talked about mass percent, volume percent, and mass volume percent. Now we're going to talk about a concentration that is not percent based. So calculate the molarity of a solution and use molarity as a conversion factor to calculate the moles of solute or the volume needed to prepare a solution. So molarity, the abbreviation is a capital M or big M, and the definition of it is moles of solute over liters of solution. So moles solute over liters of solution. So notice it is not multiplied by 100. So 100, no. So it's not a percent. In order to use molarity, it's important to review how to convert grams to moles. So when you're asked to convert from grams to moles or from moles to grams, you're going to use the molar mass. And remember that molar mass, that's the one that we get off the periodic table, and it's the number in red, the little number in red. Molar mass has the units of grams per mole. So depending on what conversion you need, you might be multiplying by the molar mass or dividing by the molar mass. Another conversion that comes up a lot when you're calculating molarity is milliliters to liters. So remember way back when we did base unit, deci, centi, milli, and it was 1, 2, 3. So if we're trying to get from milliliters to liters, so milliliters to the base unit, that's going to be 3 to the left, or divide by 1,000. So just like our other concentrations, molarity can be used as a conversion factor. So a question that you could typically see, how many moles of HCl are there in 32 milliliters of a 3 molar solution? Just like we did in the previous lecture, when you come across a concentration, you're going to make that into your conversion factor. It's misleading with molarity because you see this big M and you don't necessarily know what big M stands for. Cross it out and always write moles per liter. So your conversion factor here is actually 3.0 moles over 1 liter. So our roadmap is going to look like so. We are starting off in milliliters. We're trying to get to moles. If we go milliliters to liters, then we can use this conversion factor and go from liters to moles. So we have 32 milliliters over 1,000 milliliters, or you could have just done 3 to the left, over 1 liter. Multiply that by our conversion factor. I can just take it and use it as is, 3.0 moles over 1 liter. So for significant figures, I have 2 sig figs here. I have 2 sig figs here. Our answer cannot have more than 2 sig figs. So I end up with 0.096 moles. Okay, the next one. All right, so you're given 2 numbers. One is a concentration. This is going to be our conversion factor. It's going to be 10.2 moles over 1 liter. This will be our starting quantity. So our roadmap looks like so. Grams, and we're trying to get to liters. So grams to moles to liters. You can't go directly from grams to liters. So 21 grams over 1. And then I'm going to have to calculate the molar mass of HCl. So I'll give this to you. Molar mass HCl is 3646 grams per mole. And so 3646 grams per mole, 10.2 moles over 1 liter. So I have 2 sig figs in my starting quantity. Ignore molar mass, 3 sig figs here. My answer cannot have more than 2 sig figs. So I end up with 0.056 liters. Okay. So just like the percent concentration problems, practice is the key. Practice, practice, practice. You really need to practice these problems. So on the next page, I have practice problems, 5 practice problems, which is good. The more, the better. A few things I want to show you. Okay. So 1, what is the molarity of the solution? 2, what is the molarity of the solution? 3, what is the molarity of the solution? 4 and 5 are more like conversion factor problems where you're asked how many milliliters of something or so this is more conversion factor, number 4, and number 5 is a molarity 1. So previously, I had shown you how to convert using a conversion factor method. Now you're asked to calculate molarity. Remember that molarity is moles over liters. So whenever you're asked a question that specifically says molarity, what is the molarity? What is the molarity? You are going to have to calculate that out. Calculate this out. So you'll find each one of these numbers. You might have to convert grams to moles. You might have to convert milliliters to liters. Then you will get these two numbers and divide them out. So I always encourage students to look at the question ahead of time. And if it's a molarity question, put that there because sometimes students want to make it into a conversion factor problem and it's not a conversion factor problem. They can't have all these numbers. And a lot of times we will give you the molar mass for these problems because you've gotten to the point where you know how to calculate molar mass. And let me give you this one, speaking of on number 4. So 164.1 grams per mole. Now that one is a conversion factor, but you do need the molar mass. The last one, you are asked to calculate molarity. All right, so let's work through these. It really, when you get down to it, chemistry is just, it's like I've said many times before, it's a science of conversions. You are converting things, whether it's reactants to products, units to other units. So being familiar with how to get these units to cancel out and getting the units that are asked for is very important. All right, so question 1, what is the molarity of a solution that contains 50 grams of vitamin B1 hydrochloride and 160 milliliters of solution? So we are eventually going to get these grams to moles, and we're eventually going to get these milliliters to liters. So I'm going to say grams to moles and milliliters to liters. Once we have the grams to moles and the milliliters to liters, we can plug it in right here. This is where it comes in very handy to say, oh, you can just move the decimal 3 to the left, and I've got liters. Now notice this 0 right here is not significant. It does not have a decimal after it, so it's just going to be 0.16. And then our grams to moles, that's easy peasy. You guys have been doing this for a while now, right? So 50 grams over 1, you're going to divide by the molar mass, 337 grams, 1 mole. And so you end up, I have 3 sig figs. My red pen is dying. So sad. I go through a lot of ink. So this answer is 0.148. So that came from here, and I'm just putting that right there. Now, I'm not done yet. So I'm going to divide this 0.148 divided by 0.16. End up with 0.925. But I need to have, look at my sig figs, 2 sig figs, 3 sig figs. So my answer comes out to be 0.93, and the abbreviation for molarity is capital M, or you could write also moles/liters if you like to do that. Okay, so it is a lot easier when I kind of pointed out stepwise what you need to do. You want to get to this point with all your problems. So when you work your homework problems that pertain to molarity, be sure that you can work through them like this. Okay, question 2. 0.1 moles of sodium chloride is dissolved in enough water to make 200 milliliters of solution. What is the molarity of the solution? Okay, so we have moles already, so that goes directly right there. So didn't have to do grams. I didn't necessarily need this molar mass, but we give it to you just in case. So you really need to know what you're doing. And then milliliters to liters, I'm going to take that and move the decimal 3 to the left. And all those zeros are significant. So it's 0.1 divided by 2. I'm going to get 0.5. And I have 3 sig figs here, 4 sig figs here. My answer cannot have more than 3. So look like so. Okay. This next one, we're asked for molarity again. All right, I see milliliters. That's an easy thing to do. I can move the decimal 3 to the left, get it into liters. We're done. Now grams, I need to convert to moles. So I'm going to do 22.42 grams divided by 119 grams over 1 mole. This equals, that will go there. So I end up with 0.1884 moles. I have 4 sig figs here, 4 sig figs here, and I end up with 1.507 molar. Okay. So questions 4 and 5. Question 5, I want you to try to work on your own. It's just a molarity problem like we've been working the first 3. So hit pause and work on number 5. And if you're really daring, you can also work on number 4. Oh, and if while you're working on number 5, you wanted to know the molar mass of sulfuric acid, it's 98.08 grams per mole. So I've already converted milliliters to liters. Now I'm doing grams to moles. So I end up with 0.02401. Divide that out. I have 3 sig figs here, 4 sig figs here. So I can't have more than 3 significant figures in my answer. So 0.480 molar. And then the last question, number 4. I have 24.446 grams of calcium nitrate, and I want to make 0.450 molar solution. How many milliliters of solution can I make? So this is a conversion factor problem. This is where you cross out the M and you make this like so. Now, the trick is, how do I use that conversion factor? Using a roadmap is very helpful. So I start off in grams. I want to get to milliliters. So I'm going to go grams to moles moles to liters, liters to milliliters. So it's a good time to hit pause. See if you can work that. And okay, so my starting quantity is 24.446 grams over 1. Molar mass 164.1 grams per mole. Use the molarity 0.450 moles over 1 liter. 1 liter times 1,000 milliliters. So I start off, I have 5 sig figs, 3 sig figs. My answer cannot have more than 3 significant figures, so I end up with 331 milliliters. So molarity problems do take practice. And keep in mind on the final that molarity problems and mass, percent, or percent concentration problems, volume, percent, mass, volume, percent concentration problems, they're all going to be mixed together. So you really need to know what you're doing. The good news is the right answer is on the exam. It's a multiple choice exam. But you need to know what you're doing. And the better you know the better you are at figuring out what you're doing, the quicker it will take you and the less time you'll take on this problem, so you'll be able to move on to the next one, maybe double check your answers. So practice these homework problems. I know they're tough. I know, but you've got to continue working them. The more you work them, the easier they will become. And the good news is that what we're working on in Unit 4 is really just like what we worked on Unit 1 with unit conversion and dimensional analysis. So keep up the good work, and I will see you next time.